that Pat Rose, who is not here, but Pat is one of our project managers, and he's really been the person on the ground working with our field staff and our engineers to implement a lot of the projects I'll be talking about. So just a summary of the 2024 activities. So we conducted our standard water quality monitoring and cyanotoxin monitoring. And Lake Hopatcong is pretty unique in New Jersey and even in the United States, that it has one of the longest continuous lake databases. And you'll see why that's important, that data really provides us with some unique information that helps us to manage the lake. We've just completed the third year of a 3-year monitoring study of trout habitat, and that was funding provided through the New Jersey Highlands Council, awarded to the Township of Jefferson. We also conducted some lake restoration work, which included the installation of biochar socks. And biochar is essentially burnt up wood material, and it has an affinity for removing phosphorus and nitrogen. So it's a very cost-effective, low-tech way of removing nutrients from the water column. So we've installed 600 socks. They were distributed to the municipalities and to the homeowners, and we'll be installing another 600 this year. And then in October of last year, we conducted a large-scale alum treatment to address the internal phosphorus. So, I'll touch on that a little later.
Excuse me, Fred.
Yep.
We can only see your first slide. Are you still on your intro, your title slide?
No, right now I'm on the second slide. I'm actually on the third slide right now, which is summary of 2024 activities.
Okay. No, I'm sorry. We can't see. We only see. Oh, there we go. Now we can see the summary of 2024 activities.
Okay. All right. That's weird because I literally took it out of slide presentation. So you can see this now?
Yes, we can. Thank you.
Okay. Oh, thank you. Yeah, thank you for letting me know. So this is the slide I just finished talking about some of the activities. Some more of the project activities. We're working with, again, another grant through the Highlands Council that was awarded to Morris County to do the aeration feasibility study. And even though it says 60% of that design is complete, that report is essentially done. And we are in the process now of setting up a pre-application meeting with DEP to go over the findings of that study. We concluded work with funds, again, provided through the Highlands Council, awarded to the Township of Roxbury, to collect all the data, the ecological and engineering data for a potential dredging project in Landing Channel. And then, like I said, we're continuing to work on projects in the watershed. We've done some stormwater monitoring, the addition of the biochar. So we've been doing a lot of projects in the lake and watershed. In addition to that, this spring, as part of a National Fish and Wildlife Foundation grant, we'll be doing some riparian plantings. And riparian essentially means along a stream. So we'll be doing some plantings this month or maybe in early April along the Musconetcong River as well as Glen Brook. And installing that vegetation along those streams helps to stabilize that habitat as well as lock in nutrients that otherwise would go into the lake. We've initiated work on a couple different stormwater projects. One is a bioretention project in Jefferson Township. The other is a multi-basin project in Roxbury. So both of those projects are really focusing on reducing the nutrients that go into the lake from the watershed, primarily through stormwater. We're also working on an early detection document or plan for invasive species for both the Lake Hopatcong Foundation, and those funds were provided through the New Jersey Audubon Society. So again, we've been implementing a wide variety of projects beyond just the standard water quality monitoring. But right now, I'm going to focus on the water quality monitoring. And the one thing I do want to identify is, so this is essentially a graph of surface water temperature at Lake Hopatcong in July. And it essentially starts in the late 80s and goes up to 2024. I started working on Lake Hopatcong like in 1992. And as you can see from this graph, and this is a statistically significant increase in surface water temperatures. The July surface water temperature at Lake Hopatcong last summer was the highest surface water temperature we ever measured. It was 29.5 degrees Celsius, which is essentially about 85 degrees Fahrenheit. So the lake has been getting warmer through the decades. If you look at this graph, this is just showing you what happens when the surface waters warm up. So that graph to your left is temperature, and where you see the dark red color is the higher temperature. What this is demonstrating is as you go through the water column, there's a difference in the surface to bottom water temperatures, and that essentially cuts off the bottom waters from the atmosphere. The result is you have a depletion of dissolved oxygen in those deep waters. So the slide to your right shows dissolved oxygen, and wherever you see a bright red color, that means there's no oxygen. So that means no fish can survive in those deep waters over the summer season. But more importantly than that is when you have that lack of oxygen over the sediments, it allows the sediments to release phosphorus from the sediments, and that phosphorus can fuel some of that nuisance algae, the cyanobacteria that produces those harmful algal blooms, those HABs. So this is showing you, this graph is a long-term average of total phosphorus concentrations. And phosphorus tends to be the primary limiting nutrient for freshwater algae. So essentially what that means is more phosphorus produces more algae. And you can see that the bar is for the average concentration to be at or below that 0.03 milligrams per liter. And that's the state threshold. So we had some high concentrations in the 90s, but over the last 20 years or so, we've been implementing a wide variety of projects to reduce the phosphorus going into the lake from the watershed. And you can see we've had pretty much success from the surface water perspective. And so this is the Mid-Lake Sampling Station. You can see, though, if you look at 2024 all the way to the right, the concentrations were, they didn't exceed that 0.03, but they got close. And the thing is once you go beyond that 0.03, that's when you can have some major algae problems. So I'm showing this graph. This one's pretty important because on your left, you can see from all the efforts we've been doing with septic management, with stormwater management, you can see over the decades, we've had this reduction in total phosphorus concentrations in the surface waters, which is what we want. That's why we focus on the watershed. That's why we're working on septic management, pumping out those septic systems. That's why Jefferson Township is looking into eventually sewering. This is why we do all the stormwater projects, is to get that phosphorus under control. But if you look at the slide on the right, this is showing you that deeper bottom water phosphorus concentration. So the problem with that is that's actually been on the rise. And one of the issues is even though surface water concentrations are declining, but those deep water concentrations are increasing. Those deep water concentrations, they're not available for most algae, but some of the bad algae, like the cyanobacteria, they have gas vacuoles, so they can move up and down the water column and fuel up on that phosphorus-rich water. So that's why we did the alum treatment last fall, is to reduce that phosphorus in those deep waters. And the reason why that phosphorus has been increasing, it's because the summers are getting warmer. So we looked at this in a number of perspectives. We looked at concentration, we looked at loading, we looked at the area of no oxygen, we looked at the volume of no oxygen and how long the lake stays with no oxygen. And essentially what's happening is, as a result of climate change, we have more phosphorus being produced from the sediments. So that's why we, number one, did the alum treatment, and why we're also looking into some type of aeration or oxygenation. And I wanted to bring that up because when you do look at chlorophyll A concentrations, so chlorophyll A is essentially it's a photosynthetic pigment that all algae have. So it's measuring both the good and the bad algae. But you can see that over the last like 4 or 5 years, we've had an increase in the amount of chlorophyll A. So we've had more algae, particularly since those nasty blooms in 2019. We've had higher amounts of algae in the water column. And what that does is that results in a decline in clarity. So water clarity is typically measured with a Secchi disk. And that is what a Secchi disk looks like. It's an alternating black and white disk that we lower into the water column. And it's a very effective way of measuring clarity. Now, if you look at this figure, again, this is from 91 to 2024. And if you look at it in the 90s and the 2000s and even the 2010s, most of the time the water clarity at Lake Hopatcong was very commonly, the average was 2 meters, which is about 6.6 feet. And that's a really good water clarity. When the water clarity is less than 1 meter or 3.3 feet, that's when a layperson will say it looks cloudy, it looks dirty, it looks scummy. So we want to keep the clarity at least at 1 meter or even greater. And if you look at the data for like the last, I'd say like 10 years or 9 years, you can see this trend of this reduction in water clarity. And some of the specific data we have for some of the sampling stations throughout the lake, I'm just showing you some specific information from last year. So in May, all the Secchi depths were greater than 1 meter, which is very good. But once we got into the summer, some of the stations were less than 1 meter. And if you look at July and August, there was only one station that exceeded 1 meter. So the lake was getting cloudier, and it was particularly cloudy in 2024. And a lot of this has to do with the algae in the water. So just some notable water quality points. We did have some elevated phosphorus concentrations at some of these other stations, greater than that 0.03. You can see some of them exceeded 0.04. Station 3, which is River Styx, Crescent Cove, it had an average chlorophyll A concentration greater than 20, which is fairly high. Usually when you get to 20 or 25 micrograms per liter, that's when someone looks at the water and says it looks a little too green, looks a little too scummy. And then even the surface water densities of the cyanobacteria were quite high. So greater than 80,000 cells per mil, which is the DEP threshold of concern. So we are seeing more of these cyanobacteria in the water. Now, I mentioned we also measure cyanotoxins, 2 types of cyanotoxins. We measure microcystins and anatoxin A. So in July, when we did our monitoring, we did find some measurable concentrations of microcystin, but they were very low, fortunately. So the state threshold for microcystins is 2 parts per billion. And you can see of the 9 sampling stations, 3 of them had measurable concentrations, but they were still less than 1 part per billion. So even though we measured some cyanotoxins, they were below the state's threshold of concern, which is 2. And then for anatoxin A, the threshold is 8. And you can see, at one station, we were less than 0.4 parts per billion. So measurable amount of cyanotoxin, which is that anatoxin A, but it was below the state threshold. So that was for July. If you look at August, we did not detect any cyanotoxins at our stations. Again, this is good. We couldn't even detect them. They weren't present. And this makes sense. If you remember August of last year, August was a wet year for us. When we got into September and October, it dried up pretty quickly. But August was a fairly wet month. So it makes sense when you have a lot of flushing through the lake, it doesn't give the algae the opportunity to accumulate and produce those toxins. So in conclusion for this part of the presentation, there are concerns over reduced amounts of plant growth. And when I say plant growth, I mean the submerged plants that grow from the sediments up. And again, this is partly attributed to the water being cloudier. the clearer the water, the more plant growth you have. And I always tell people I'd rather have people complaining about the plants than the algae. Because if we have clear water and a lot of plants, the plants produce habitat and food for all the aquatic organisms. They help to stabilize the sediments. They help to produce oxygen. And we have a fairly effective program of mechanical harvesting to keep the plants under control. And then some, I know property owners also use aquatic herbicides to control the plant growth. So there are a number of ways of managing the plants. Once you have a large harmful algal bloom, it's very difficult to get that under control. And then obviously those harmful algal blooms produce cyanotoxins, which could lead to the closing of beaches. So of the two problems, definitely would prefer the plants over the algae. Again, to battle the algae, we conducted the alum treatment, and we're looking into aeration to address that internal pool of phosphorus coming from the sediments. And then I'll be talking about a Army Corps project as soon as I'm done with this part of the presentation. The last thing I do want to emphasize is this winter has been more of a normal winter. So over the last 2 winters before this one, we had very mild winter conditions. Donna and Marty forwarded photos to me of people actually boating on Lake Hopatcong in January and February. So we didn't even have ice cover. This year we had ice cover. And the fact that we had ice cover should help the lake in terms of it slows down that biological productivity of both plants and algae. So we're hoping between the alum treatment and more of a normal winter, we should have a better year of water quality this year compared to past years. So I'm going to wrap up here. I keep talking about we want more plants and less algae. So just to let you know, we're working with Army Corps, with the Army Corps of Engineers with their ERDIC, or their Engineer Research and Development Center. We were awarded a grant to implement various innovative technologies to either proactively or reactively deal with nearshore harmful algal blooms. So the issue is, okay, we know that external nutrient loading comes from the watershed. Internal nutrient loading comes from those deep water sediments. But we also know that these shallow nearshore areas, all the bays and coves, are where a lot of the cyanobacteria start at the beginning of the growing season. So they tend to grow on the sediments, they'll float to the surface, and then they impact the lake. So what we wanted to do is we wanted to evaluate various ways of treating or managing those overwintering algae. And I like this, that one of our marketing people put this together. This is essentially what we'll be doing for this project. So you can see the person in the boat on the right doing some sort of product. And some of these products are registered pesticides. Some of them are nutrient inactivators. And I'll be going through some of those shortly. But you can see we're adding the product, and then we're doing water quality monitoring. And then we're going to evaluate how effective they are at reducing the overwintering algae. And then for Army Corps, they want us to do a cost benefit analysis. So this is what we're doing under this grant. So we have 6 project locations. You can see they're all highlighted in red. And notice they're all near shore locations. So we have 2 that are going to be run in the spring, 2 in the early summer, and then 2 in the mid to late summer. As part of this, we're going to be doing some pre and post treatments of incubation. So we collect some of the sediment from these coves and the overlying waters, and then we'll incubate them to see, okay, what types of algae are growing in those areas. And we started doing projects like this in 2023. And I'll just throw this one thing out that we found from Smith Mountain Lake in Virginia, that where you have organic silty sediment, that's where we saw a lot of the cyanobacteria originating from. In contrast, if you had very sandy sediment, that wasn't a good source of the cyanobacteria. And that's really important, because if you have a cove that has a lot of sandy sediment, there are certain management techniques you'd want to implement versus if you have a lot of organic sediment or silty sediment. So that's really important. And we'll be using that methodology in Hopatcong this year. So again, I don't want to dwell too much on this. We'll be monitoring for a wide variety of parameters, temperature, dissolved oxygen, pH, conductivity, water clarity with the Secchi disc, various pigments that the cyanobacteria produce. We'll be seeing if they're producing the cyanotoxins. We'll also be doing what's called qPCR analysis to see if the cyanotoxins, if the cyanobacteria actually have the genes to produce the cyanotoxins. We'll be measuring nutrients. We'll be evaluating the submerged aquatic vegetation. So I'm just going to wrap up the presentation to go through what these treatments will entail. So again, we have 2 spring treatments that are coming up in a few weeks. So the first one is in Ashley Cove in Jefferson Township. It's a 2-acre cove. We'll be using a standard algicide. It's a copper-based product, but it's a chelated product called Q-Trine. But instead of treating it once you have a bloom, what we'll be doing is we'll be treating immediately over the sediments at the beginning of the growing season, so in April. And the thing we're trying to do is, can we either prevent or at least delay the development of a HAB by doing this more proactive treatment? The whole idea is, can this proactive treatment replace multiple treatments of a copper-based algicide over the summer season? So that's the first project. The second project in Crescent Cove is to use a strong oxidizer, which is called PAC-27. So again, very similar that, and we haven't, but the commission has funded, I think 2 or 3 summers ago, a oxidizing treatment in the Crescent Cove section of the lake to try to get an algal bloom under control over the summer season. Again, this is going to be more of a proactive treatment. We're going to do it in April, and we're going to try to do it immediately over the sediments, again, to see, can we either delay or prevent the development HABs in that section of the lake. So those are the spring applications. For early summer, we'll be going into Landing Channel. We're doing something called Flock and Lock, where we're using a product called chitosan. Now, chitosan's interesting. It's basically ground up exoskeletons of, say, like shrimp or lobster. And the stuff has a high affinity for dragging algal cells down. So what we'll be doing is we're going to be using a combination of the chitosan and something called Ecological G, which is a binding agent for phosphorus. So we're using this flock and lock where the chitosan flocks out the cells, and then the Ecological G is going to lock the sediments into the phosphorus so it's not available for algal growth. So that's going to be done at Landing Channel. In the opposite end of the lake, so that was down in Roxbury on the southern end. This is up in Jefferson. In Northern Cove, we'll be doing what's called a flock and sink, where we're using alum, again, to flock out the algal cells. Alum is very commonly used in drinking water supplies to clear the water up. And then we're using a heavier dosage rate of the Ecological G as a sinking agent to bring the nutrients and algal cells down to the bottom. Again, these are proactive ways of trying to manage these HABs before they occur. Then the last 2 treatments are mid to late summer. So these 2 treatments will be designed to be conducted during a HAB. And, talking with the commission and foundation, it was determined that we would identify Great Cove and Van Every Cove as a result of the prevailing winds and what happens over the late summer season. We have this accumulation of the harmful algal blooms. So this treatment here is called a kill, flock, and sink. So here we're going to be using an oxidizing product again. This one's called Green Clean, to break up the algal cells, and then the chitosan will flock the cells out, and then the Ecological will sink them and lock the phosphorus in. So this is called kill, flock, and sink. And then the last treatment is just called kill and sink. So here, again, we're killing the cells and then sinking the dead cells and the associated nutrients down into the sediments. So these are pretty innovative treatments. They're not your standard copper-based treatments. And one of the things that Army Corps really liked about these is they're demonstrating things that have been done in the lab, but they have not been done in the field. So we're actually going to evaluate whether or not these strategies are cost-effective ways of either preventing or minimizing the impacts of harmful algal blooms. So, and then this is just showing you what we'll be doing for the analysis. So we have to collect a lot of data, and we have to do a statistical analysis of whether or not we can determine that those treatments were effective. And then Army Corps wants us to do a study where we're going to calculate the cost on a per acre basis. So this is information that then Army Corps releases to the public, so that Lake Hopatcong, other lakes in New Jersey, or any lake in the United States can then use that data to make a determination on whether or not this particular treatment or this particular management technique may be an effective way of them dealing with their HABs. So that's what I have for the presentation. It will be interesting because next year, hopefully what I'll be able to do is I'll be able to present on some of these findings. And that's what we're hoping to do with this study. We'll present this to both the Commission and Foundation, as well as DEP and Army Corps. So thank you for your time. I appreciate it.
Thank you so much, Fred. That was very informative. Before I open it up for questions, I do have one question that I wanted to pose to you. Getting funding through Army Corps is very competitive. It's not being involved in lake management for over 2 decades, working in the grant field. So how did Princeton Hydro become aware of this? And Lake Hopatcong, relative to our lakes nationwide, is a very small lake. So, that we got this money through Army Corps is just wonderful. But can you talk a little bit? Because this is directly with Princeton Hydro. It's not going through the foundation or the commission, correct?
Correct. So it was a long and winding road. And I can tell you, part of it is your legislators, that when the HABs hit in 2019, it not only hit Hopatcong, but it hit a number of lakes in New Jersey. And as a result of that, your legislators put into some of the legislation for Army Corps. So there was a program back in 2022 where funds were made available for these types of studies. And it was a very small group of lakes that they were focusing on. They were focusing on the Great Lakes, and they were focusing on lakes in Florida. As a result of the HABs that hit New Jersey in 2019, your legislators, particularly I believe Mickey Sherrill, made sure to include Lake Hopatcong on that list of lakes that were available for that funding. So that's the first thing that happened, was the legislators identified not just lakes in Florida, not just the Great Lakes, but lakes in New Jersey, and they specifically identified Lake Hopatcong in that document. So that all of a sudden made the chances of you receiving funding, it substantially increased. Because like you said, Donna, anyone could apply for that. But if you're in that list in the legislation, that short list, it improves your chances. In addition to that, I went to a conference back in 2022 where I met some of the Army Corps people, and I talked about Lake Hopatcong. I had a poster on the lake. I was talking about the internal versus external loading. So I started a dialogue with them, and that helped. And then even the incubation stuff that we're doing, basically that protocol, I was inspired to use that from Army Corps. Army Corps started that protocol. I saw some presentations in 2022, so we adopted it and now we use it. So I think it was a number of things. One was the legislation. Two, it was starting the communication with them. And three, I think it helped that we're actually using protocol they developed to evaluate how effective these are. The other thing too is a lot of times for these programs, a lot of the projects are for like these real elaborate, very expensive ways of dealing with HABs. So like maybe a floating vessel that will take the HABs, press it, dry it, and it can be very effective, but those systems tend to be extremely expensive. So there are some of those systems that are floating, but some of them cost as high as $20,000 to $28,000 a day to operate. The thing that they really liked about our proposal is we were evaluating things that have only been done in the lab, and we're looking at things that would be relatively low in cost compared to some of those other technologies. So I know it's a long-winded answer, but it was a long and winding road to get there.
Well, thank you, Fred. I mean, I think that's great that Princeton Hydro is out there looking on behalf of Lake Hopatcong to come up with innovative solutions and going after the money because that's what we rely on you for. So thank you. So at this time, I'd like to open it up. If anyone has any other questions for Dr. Lubnow, we're happy to take some.
It's Larry. May I ask a question?
Sure, Larry.
Following up on your question about the grants, is the Doge program in Washington, do you think that's going to be affecting grants generally for us?
That, you know what, that's a really good question, and that's something that we ask Army Corps. Are you concerned about this? And they're like, look, we're moving forward. We're moving forward. They haven't heard anything. Don't know if they will, but for this program, that money was allocated back in 2022. Now with Doge, who knows what that means if that money is already allocated. But for this project, we have been moving forward, talking to a couple people from DEP. I mentioned a few weeks back, we had a virtual conference with Army Corps, and some of the DEP people were surprised that that conference was still on. And I said, look, Army Corps is telling us to move forward with everything, so we're moving forward. Now, they did have another HAB program that released funds for 2024. And right before the turn of the year, we did submit some proposals for that. I think if anything has an issue that may not get funded, it might be that 2024. So yeah, we don't know how this is going to affect the program. We are constantly asking Army Corps, is this an issue? And they're saying, we're not getting any word to shut anything down. We're moving forward. But that's a really good point. We don't know what's going to happen, but they're telling us to keep going.
Great. Thank you.
Thanks, Fred. I see a hand up by Greg, but I don't think it's a Greg.
Greg,
Hi.
can you hear me?
Yes, we
I'm
can.
not Greg Hancock.
Yeah.
I'm Rhoda Shermer, but I'm using Greg's link. We're neighbors. And somehow I missed out on noticing that you were doing this Zoom. So I'm glad he sent that to me, and I'm glad to be here. And thank you for your very nice report, Mr. Lubnow. Okay,
Thank you.
so the real Greg Hancock and the phony Rhoda Shermer are residents of Raccoon Island. And we are in a cove area, and the water is not as deep as elsewhere around the lake. And I was wondering, since we suffer greatly from the weeds, and the weed cutter that's often in service is not able to get into the cove area because they're afraid of rocks and stuff that they can't see. So I'm wondering what the scope of what you're doing, how it can help us.
Well, it will. Yeah, it will definitely help in terms of reducing the algae. Now, for the plants, that's something that we should look into. I can tell you that we're submitting a proposal. When I say we, the Township of Jefferson will be submitting a proposal to do an aquatic plant survey. What I'll do is I can add Raccoon Island on that, because the first thing we'd have to do is identify what plants you have in there, so we could better understand how to manage them. So what I'll do is I'll talk to our field staff, and I have to finalize that proposal and send it to Jefferson so that they can then send it to Highlands. But what I'll do is I'll add. Where are you? Are you on the northern end of the island?
Oh, we're near the ferry.
Okay, all right.
And there's a cove there, and I think on the map from years ago, if I recall, the name says Pleasure Bay or Pleasure Cove.
Okay.
And a number of us within that cove area, about 6 or 7 homes, would really love to know what's possible, because it's getting really crummy.
Yeah, what I'll do is I'll make sure we include that in the survey, because the first thing I want to do is, identify what plants are of issue. Now, I don't get out unfortunately, I don't get out on the lake near as much as I used to. But when I used to be out in the field a lot, I remember a lot of broadleaf pondweed growing pretty high in that section of the lake. I don't know if it's still broadleaf pondweed. I know there's another cold species called curlyleaf pondweed that's been expanding in the lake. So I definitely want our field team to identify what plant you have. That's the first thing we have to do. Once we know what plant you have, then we can provide some recommendations on how to deal with it.
That's great. Now, how do I keep in touch on this issue so that I know what is happening? And actually, I wanted to ask, is there a way of getting this report, that what you're doing, so I can share it with others?
Sure, yeah. So the like Donna mentioned, the water quality reports are all put onto the commission and the foundation's website.
Okay.
But probably the report you'll really be interested in is the one that we'll work on this year. So that one, we'll be doing that plant survey. We'll be doing the plant survey in August, but we're on the lake May, June, July, August, September. So those reports will be available toward the end of the year, and those are the ones that you'll probably be most interested in. So, and how I would recommend you stay in touch is, attend the Lake Hopatcong Commission meetings. They meet once a month, or reach out to Colleen, or reach out to Kyle or Donna or some of the people at the Lake Hopatcong Foundation. I mean, keeping in touch with the commission and foundation, they'll be able to tell you what's the status of specific activities. And then once those reports are available, they almost always put them online. I mean, almost all of this data
they're doing a great job. They are.
Oh, thank you. It's public information, so it's all available.
Okay. The thing is about Raccoon Island, and I don't know about the other guests on this program, it's really a summer community. We're not around all year.
Okay. Mm-hmm.
Oh, I did put my email address in the chat. It's kyle@lakehopatcongfoundation.org. If you wanted to email me, we can connect. We connect regularly with a number of Raccoon Island residents as well, who we can also keep up to date, who can share information with you. But if you just want to send me a note, we can make sure that we connect, and I can keep you updated on the work that the foundation is doing, the commission is doing, and that Princeton Hydro is doing.
Great. That's great.
Yeah.
Thank you so much.
You're welcome.
Thank you. So I'd like to continue to open it up to any other questions for Dr. Lubnow this evening.
I have a quick question. Can you guys hear me or no?
Yes, we can.
Maybe I missed this, Fred. You said you would do a presentation at the end of all the studies. Do you know when that'll be? They're going to be comparing it to 2026. So will that be like end of 2026 that you might have that data?
Yeah, so we'll do one at the end of 2025 after all the field work's done, and then we're spilling into 2026. So I would guess like halfway through 2026 would be the second presentation. And a lot of this stuff, I'm like, Pat Rose, who's really, I mean, he's the one who's managing the project. He'll be talking at the HAB Summit, where he'll be talking about what we're doing. But then next year, I imagine Pat will really be the person who'll be presenting a lot of this data, but at least two presentations, one at the end of 2025, and then the second one, I would say probably in halfway through 2026.
Thank you.
Yep.
Hi, can you hear me?
Yes, we
Yes.
can.
All right, this is the real Greg Hancock. I'm actually up in Burlington, Vermont, and
Oh, okay.
we live on Lake Champlain. Well, I mean, the city is
Nice.
on the Lake Champlain. We have exactly the same problems on a
Yep.
different scale than you do here with the HABs, with the cyanobacteria.
Mhm.
Our lake is loaded mostly from the dairy industry, from the farms,
Mhm.
which is a real problem. It's a constant battle between the state and the EPA and the people that are downstream or live the consequences of it. But also we have some stormwater runoff from the city. Our city is right on the lake, and occasionally with the increased flooding we get from these unusual storms.
Mm-hmm.
It overloads the municipal septic systems, and some of them are combined. So when they get overwhelmed, they just kind of dump out of the treatment plant right into the lake.
Yep.
So and we have a very good, commission up here that tries to be a good steward of the lake and things. But my question is, what is the load of Lake Hopatcong? I understand a lot of it is the bad septic tanks, and you had mentioned that Jefferson is hoping to go to public sewer, public treatment, which would be great, and I would love to see some action on that. But is that the major source of load, or and the fertilizers, of course, on the green, and people use on their lawns and things like that?
Right. Yeah. So when you look at the annual phosphorus load for Lake Hopatcong, between like 80 to 85% of it is coming through a mix of stormwater and septic leachate. So it's a combination of the two. And it's one of the reasons why for the last 20 years, we've really been focusing on watershed management. Historically, when you look at the phosphorus load on an annual basis, that internal phosphorus load has only been about 10% of that annual load. But what we found in 2019 when the HABs hit is the HABs were stimulated by the watershed load, but the reason why they persisted for the whole summer season was because of the internal load. So we did a 30-year data analysis of all the data we have at Lake Hopatcong, and even though on an annual basis the internal load is less than 10%, what we found was during the summer, and if the summer was dry, the internal load could account for up to 70% of the available phosphorus. And as I mentioned, the bad algae, the cyanobacteria, they have these gas vacuoles so they can move up and down the water column. So if you have all this phosphorus-rich water in the deep water, they can collapse those gas vacuoles, sink, fuel up on all that phosphorus, they create more gas vacuoles, and then they float to the surface and make those surface scums. So to answer your question, about 80 to 85% of the phosphorus load on an annual basis is coming from the watershed. But if you look at it on a seasonal basis, that internal load can be large, which is why we had to start looking at that internal phosphorus load. So it's sort of those, we have to deal with both the watershed based and the internal based.
Right. And a lot of that is the warm temperatures in the summer. That's
another thing too. So when you have those warmer temperatures, again, the bad algae prefer warmer temperatures.
Right.
So the good algae, the algae that are basically the base of the food web that the little zooplankton eat, and then the little fish eat those, and then the big fish eat the little fish. The good algae prefer cooler water temperatures or even warm water temperatures. But when it gets really that hot, like in the 80s, the cyanobacteria do best. So cyanobacteria really need three things. Number one, they need elevated nutrient concentrations. Two, they need higher water temperatures. And three, they like when things are just sitting there. You know, if there's a lot of flushing, you don't see as many of the cyanobacteria. Right. So those are the real three things that they need.
Right, great. And just one more question, while I still have your attention. Can you tell me about the efficacy of the biochar? Because, you know, I also represent a group up here that we are fighting biochar because of what it's doing, you know, to our forests, cutting trees and burning them for. And
yeah, so
there's some. I think the jury is out on the efficacy of it, and I'd like to hear your opinion.
Sure, yeah. So we've been using biochar since about 2020. And we've gotten some very good results in terms of installing it in these socks and then installing them in aquatic systems where we get a good removal of phosphorus. So there are two stormwater ponds, Duck Pond and Memorial Pond in the watershed. And where we've installed them, we've gotten between 70 to 80% of phosphorus removal. And then we've also installed them in some of the ponds in Central Park. We've installed them in several lakes up in the Poconos. We've done a number of locations. And again, like anything, it's not a magic bullet. Where we see the highest removal rates are in standing water. So we've tried installing them in streams, and the highest removal rate we get is maybe 50%. But more importantly, in streams, when a storm comes, no matter how hard we try to anchor the biochar down, it always either blows out or it's up on the bank. We always have some issue because of strong storms. So we prefer to put them in standing water, and they're best served in like stormwater ponds. That's where we get the highest removal rates. But one thing that we're actually working on, and we're talking to some people up at the University of Vermont, we're getting these high removal rates if you sample upstream and downstream of where the biochar is installed in the pond. But when we measure how much phosphorus is in the biochar, we're not getting the high concentrations we're seeing. So we're wondering where that biochar is going. So one of the hypotheses is a lot of the microbial growth in the biochar might be using those nutrients, and we may have some grazers feeding on it. So we're actually talking with some students up at the University of Vermont and maybe working with them to try to figure that out. So I can say we have a decent amount of data to show when we install these biochar sleeves in these smaller stormwater ponds, we can get some pretty good removal rates. All of our data is exclusively phosphorus, so we want to look into nitrogen as well. But we have seen it be a useful tool. It's not a magic bullet, and it's not the cure-all, but it definitely, we've seen it help in terms of reducing available nutrients.
Okay, thank you very much.
Yep.
Okay, that was very informative. Thanks, Fred. So
Sure.
before we close it out, I just want to put one more call out for any other questions for Dr. Lubnow. It's not every day we get to take advantage of his years of working on our lake.
I have another one, if you don't mind.
Sure.
Dr. Lubnow, I live on Byram Cove, and I saw the very nice distribution of alum treatments last year. I'm just wondering if you have any preliminary results of that treatment.
Sure. So we did get one sampling event after the alum was added. And I can say immediately over the sediments, we saw a 70% reduction in the available phosphorus comparing before the alum treatment to after the alum treatment. So that's a good sign. I mean, the real test will be monitoring this year. I gotta admit, I was very nervous. Typically, I'm used to doing an alum treatment at the beginning of the season in the spring. But because of permitting issues, we had to do it in the fall. I was very nervous because fall, sometimes the weather can be, iffy, and you want like nice, sunny, dry conditions when you're doing an alum treatment. And thank goodness we lucked out. I mean, in a way, it was bad. We had a very dry October, but for the alum treatment, it was perfect weather, because what you want is you want that nice, calm weather. So as the alum, it's heavier than water, so it's sinking, and you want it laying over the sediments, because what happens is that when that phosphorus is coming off that sediments, you want the phosphate ion to connect to that aluminum ion, and then it's unavailable for algae growth. So next year we'll have actual data to show how effective the alum treatment is. But again, I feel good the way the weather was when we did the treatment. It went off a lot smoother than I was afraid it would happen. So I was very happy about that.
Thank you.
And Fred, just a follow-up question on that. Does Princeton Hydro do any different types of monitoring for the alum treatment, or is it the standard monitoring that you typically do?
So two things with that. One is to minimize costs. What we're doing is when we do our standard 5 monitoring events, we'll also be collecting additional data for the alum. So the additional cost is just the lab fees. It's not additional labor and boats and everything. But the other thing too is last year, DEP in July put out a new permit for HAB management. And fortunately, the permit is it's a fairly simple permit. It's similar to a aquatic pesticide permit, but it's specifically for non-pesticides treatment. So it's for treatments either for nutrient inactivation like alum or the bacterial products. So we had to file that permit, and that permit had some additional monitoring. So we did have to include some additional parameters under that permit. So any additional fees, fortunately, are covered under the existing grant. And like I said, no additional labor because we're already out there doing the monitoring.
Thank you, Fred. Okay, before we wrap up, I just wanted to say thank you very much to Dr. Lubnow for being on and for all of you for joining us this evening. We hope you found it informative, and we encourage you, if you haven't already, to go on to our website or the Commission's website to read the water quality monitoring reports. And also, as Dr. Lubnow mentioned, the Lake Hopatcong Commission holds their monthly meeting. I believe, and Kyle, correct me if I'm wrong, they're typically on the second Monday of the month at the Lake Hopatcong Foundation office, and they are open to the public. So if you want your voice to be heard or to learn more about what's being done, we encourage you to participate or attend those meetings. So thank you all for joining us this evening, and have a lovely night.
Thank you.
Thanks so much,
Thanks,
Fred.
Fred.
Thanks, everyone.
Appreciate
Thank
it.
you.
Take care.